Okay, today we're going to do the density of different materials lab. Our problem is we're going to look at what are the densities of the materials listed on the data table. So on your sheet, you're going to have a data table, and to the far right, you have a spot for your hypothesis. I want to know what you think the density is of each of those 10 objects. Remember to write the units next to each of your numbers. Okay, so your objects are listed. You have the copper strip, which we have right here. We have the cube, which is, get it out, right here. We have a copper cylinder, an aluminum cylinder, an iron cylinder, a brass cylinder. I'm trying to get it so that you can see them, and obviously you can't. A large steel ball, small steel ball, a marble, and a cork. Okay, so the first thing I'm going to do is show you the mass or tell you the mass of each object. I'm going to place my copper strip right on my balance here, and it says it is 13.6 grams. So write that down under mass right next to copper strip. The cube is 0.6 grams. Write that one down. The copper cylinder is 57.1 grams. Write that one down. The aluminum cylinder, 17.2 grams. Write that one down. The iron cylinder is 49.1 grams. And the yellow brass is 53.6 grams. Remember to have the little g next to each of these numbers. We have no naked numbers. Now, the cork, which is way at the bottom, is 0.6 grams. The rest of these items roll around, so we need to place them in an object, which we call the weigh boat, so that we can keep them contained. I'm going to zero out or tear the mass so that the mass of the weigh boat is not included. The large steel ball is 67.5 grams. The small steel ball is 28.5 grams. And the marble is 5.2 grams. Okay, so now we have our mass done for all of our objects. I like to do them all at one time. I get that column done. I can move my supplies out of the way, especially because we're using water and an electronic balance. Water and electricity do not go together. Okay, so here I have a graduated cylinder. I have 40 milliliters of water in my graduated cylinder. The first thing we're going to do, though, is get the measurement of all of our items that use water. So I can get that out of the way. That's going to be anything that's an irregular shape. Okay, I have a second graduated cylinder that's empty so that I can pour water from one to the other and try not to make too much of a mess. So the first one I'm going to do is my copper cylinder. Remember your starting point. When I drop this, the water level is going to go up. That's called the ending point. You take the ending point, subtract your starting point, and the difference between the two is the volume of your object. So we're going to go from 40, gently put it down so it doesn't splash out. It went up to about, let's see, 45, 46, I'd say about 46 and a half, 47. So that means 6.5, or you can write 7. Okay, your choice how specific you're going to be on this. That's where we have human error, since we don't have an exact measurement. All right, set that one to the side. Then I will do the aluminum. We're still roughly at 40. Drop that one. That one's at about 46, so that means it went from 40 to 46. It's 6 milliliters. I'll do the iron one. We're still roughly at 40. Drop that one down. That went to 46.5, so it's about 6.5 milliliters. We'll do the yellow brass, still at 40. Yellow brass is at about 45.5, so I'd say it's about 5.5. You can round up to 6 if it makes you feel better. Okay, now I'm going to do the marble. The last one I'm going to do with graduated cylinder is the large steely in case it makes a big mess. So the marble, we're starting at 40. That went up to about 42, so that's going to be about 2 milliliters. Let's do the small steely, 40. And that went up to 44, 43.5. All right, let's do the large copper, large steely. Splattered a little bit, but not too bad, so it went from 40 up to about 47, so that means it's about 7 milliliters. The last one we're going to do is the cork. Remember, the cork's going to float, so we know the density is less than 1, but we're going to try and figure out, we started at 40, we need to push it down just enough to cover it. And so it has a volume of about 3 milliliters. Okay. Get that out. Okay, now with the other two objects, we're going to use the ruler. That's the second way of getting the volume of an object. So with my ruler, we're going to use the centimeter side because we're in science class. Remember, you have to take 3 measurements, the length, the width, and the height. So for the copper strip, I take it, put it on my ruler, and it's about, I'd say 15 centimeters for length. We're going to multiply it by the base, well, it would basically be the width, and that's going to be 2.5. So 15 times 2.5, and then that was the height. The width, we're going to say, is 0.1. So 15 times 2.5 times 0.1. When you get that number, you'll write that in the volume and label it centimeters cubed, which is cm with a little 3. That 3 represents 3 measurements taken. My cube, I'm going to put it on the ruler. It's 1 centimeter for length, 1 centimeter for width, 1 centimeter for height. 1 times 1 times 1 is still 1, and label it centimeters cubed. To figure out the density for each object, remember it's the mass divided by the volume, and then you have to show both units, the grams per centimeter cubed. The per is going to be a forward slash line, so G slash cm3, or grams per milliliter if you measured with water displacement, G slash ml. You can't just write grams per milliliter and call it good, because you have to show how the volume was taken. So make sure you have the proper units. That's where people lose points. If you look at your questions, pretty much 1, 2, 3, 4, 5, and 6, you can just answer real easy. 7, you have to take your data from the first page, put that on the data table that says experimental density. Use that information. you're going to take the table of density information from that resource sheet I gave you. So look that information up. And then you're going to take the difference. Take the big number minus the small number. That number is your difference. And don't forget units for all three columns. 8 through 13, answer. Where it says explain, that means you explain. Write incomplete sentences. Okay? You do need your textbook because you're looking at a picture on page 363 for numbers 9, 10, 11, and 12. Number 12 is asking for the what happens when you add antifreeze. And if you look at the table of density sheet, it's called Ethandoil, and in parentheses, it's called antifreeze. So make sure you look at that as well. Okay, number 13, give me the procedure for taking 2 unmarked containers. I don't know which one's oil and which one's syrup. They're not labeled. You can't smell, taste, anything like that. So you're going to have to figure out using your table of density. Any questions, please contact me. Have a great day.